Poseidon is a model that describes the behavior of individual fishers, called agents. It is therefore called an agent-based model. It simulates how fishers will respond to different policies, market changes, and environmental conditions. In Poseidon, fishers adapt their fishing strategies based on regulatory changes, stock levels, or environmental conditions. For instance, fishers might start fishing more when the season is shortened, or fishing along the borders of a marine protected area if those are introduced. Poseidon focuses on the decisions, strategies, and actions of the individual fishers, helping us to understand how individual behavior impacts larger socioeconomic and ecological systems. Poseidon's main strength is its ability to model a fishing fleet in as much detail as is available. Traditional models don't capture this adaptive nature of fishers, making it difficult to anticipate the long-term outcome of policies, as fishers and fleets might respond differently to policy changes, market fluctuations, environmental conditions, or resource availability. Poseidon also allows you to define regulations in a very flexible way, making it possible to explore practically any policy scenario. You can also track outcomes such as total landings, fleet profits, and you can also follow the behavior of individual fishers and see how regulations affect them. Poseidon has been used to help address concrete management challenges in California, Indonesia, and in the Eastern Tropical Pacific. In California, Poseidon was used to model how fishers in the West Coast groundfish fishery would react to new individual transferable quotas and bycatch restrictions. In Indonesia, Poseidon was also used to evaluate the interventions that would be needed to help rebuild the Malabar blood snapper stock in the Java Sea. And currently, Poseidon is being used by the Inter-American Tropical Tuna Commission to study the impact of fish aggregating devices in the Eastern Pacific Ocean. The model shows that limiting active fish aggregating devices by about 20% could significantly reduce environmental impacts without harming overall catches. Although Poseidon is very detailed at the individual agent level, its limitation is that it does not represent the whole ecosystem in as much detail as other models. Uncertainties include those related to the behavior and decision-making of the fishers or fleets, which might not be fully understood or quantified. With the Surimi project, we're making Poseidon more robust and easier to use, and we will integrate it into the digital twin ocean infrastructure. We're also building bridges with other Surimi models, so that they can be used together for management strategy evaluation. For example, by combining Poseidon with EcoPath with EcoSim and the system dynamics model, we will simulate both individual behavior and the broader ecological and socioeconomic impacts. For example, Poseidon can simulate how fishers adjust their behavior in response to market conditions or fishing policies, while EcoPath with EcoSim can track how those changes impact ecosystem health and fish stock dynamics. This allows for a more accurate representation of how individual actions influence both ecological outcomes and economic feedbacks, reducing model uncertainty.